Everybody got a note sheet? Yes? Let's go and put the Chromebooks away for now. Okay. Yes. So, what we're doing today is dividing rational expressions. Now, it'd be similar to dividing fractions. Now, would we actually divide these here? Well, not really. Because what do we do when we divide fractions? Well, we change it from division to and flip the other fraction. Yep, keep, change, flip. Now, and then we would multiply, or really we could see that's the same as 2 over 1, because it was 1/2, it becomes 2 over 1, and then we can multiply 6 times 2, which would give us 12/7. So really with dividing these rational expressions, what are we doing? We're taking it as written as division, changing it from division to multiplication, and doing exactly what we did the other day. So when we look at something like this here, really, we have it set up to as division, and we would be dividing these two here. And I'm just going to go on and just rewrite it for now. But we're going to change it from division to multiplication and flip the second fraction. So we have x squared minus 11x plus 30 over x squared minus 6x. So division isn't on a huge part different than multiplication, because we're taking it from division, changing it from division to multiplication, and flipping that second fraction. Now, everything else that we do is going to be the exact same thing as what we did yesterday. So we look at this here. Okay, well, we have two fractions being multiplied. So let's look at 7x. So how can we factor 7x? 7 and 1, which would just really be 7x. Since we only have one term, there's not much anything we can do. We just leave it as 7x and call it good. Now 2x minus 10, what can we do with it? Is there anything we... Yeah, we can factor a 2 out. We can factor a 2 out of both terms. 2 factored out of 2x would give me x minus, well, 2 factored out of 10 would be 5. So we have those done. Now, do we want to factor x squared minus 11x plus 30 first, or x squared minus 6x? Okay, so x squared minus 6x. So what can we do? We can factor out an x. And if I factor an x out of x squared, I'm left with x. And an x factored out of 6x leave us with just 6. So we can factor an x out and get x times x minus 6. Any questions on any of this here so far? Are you good with this here? Okay. Now lastly, we have to factor the numerator, our x squared minus 11x plus 30. We need to factor this here. Now when we look at this here, well, the factor, since 30 is positive, the signs are the same, and they match the sign of the middle term, which would be negative and negative. We'd have those two negatives, or two minuses. Well, the factors of x squared are going to be x and x. Now we need the factors of 30. Well, 30 is 1 and 30, 2 and 15, 3 and 10, and, well, not 4 and 5. It would be 5 and 6. So we listed all these factors out, and I listed all these factors out. Now looking at these here, what would be the factors of 30 that we would want to use? 5 and 6. Because again, we're wanting things to be in common on top and bottom of this fraction, yes? The one number that we do, or one set of parentheses I do have on bottom is x minus 6, yes? Well, hey, I also have x minus 5. So if these work as factors of our x squared minus 11x plus 30, they would simplify on top and bottom. And it does work out if we do the multiplication. If we check this, erase this here. Check this, x times negative 6 would be negative 6x. Negative 5 times x would be minus 5x, which would give us our negative 11x like we wanted. So this does work. Okay. Any questions on any of this here so far? Any questions on how we got to this point? Well, now we can multiply them together. Or we can be lazy and just draw a line to connect the two. Because they're all being multiplied together. So we could rewrite them, or we can just connect the two. And now we simplify what's in common on top and bottom. Yes? So what is in common on top and bottom? And anything else? X and x. So what is left over? Right, 7 over 2 or 7 halves. That's all that's left, yes? Okay. Extend the page out a little bit. So we need to talk about our restrictions, yes? Because we cannot have the denominator be what? 0. We can't divide by 0, correct? So we would have our x minus 5 would be 1. And that would be it for the first fraction. The other fraction we would have x and x minus 6, yes? Are those the only places we need to look for zeros? I mean, those are definitely the places that will cause us to divide by 0, correct? So I'm just looking back up here at what we started with. Let's get a highlighter. So I know that 2x minus 10, if that becomes 0, I'm dividing by 0, correct? Oh yeah, because that's in the bottom of the fraction. How about x squared minus 11x plus 30? Well, if that becomes 0, I'm dividing by 0 again, yes? Well, let's change colors. What would happen if x squared minus 6x became 0? What would happen to this here? Well, if the numerator is 0, the whole thing is what? 0, yes? So that would be 0. Is that an issue? What are we doing? So if the second term, that second rational expression becomes 0, I'm dividing by what? 0. So with division, we're not just looking at the denominators. We also have to look at the second expression as a whole term. Well, for this here, it's not going to make a difference. Why is that? So what are the top two terms here? Well, we have what? X minus 5. Yes? Was that already listed? How about x minus 6? Oh, yeah. We already have them. Just because they appear more than once doesn't mean the 0 has to be repeated more than once. We only need it listed once. So here, having them repeated doesn't make a difference because we already have them. Now we just need to figure out what they are. So none of these can be 0. X minus 5, we can't have it equaling 0. We can't have x equaling 0 and x minus 6. So we'll set them equal to 0 to find out what values of x, or what values x cannot be. So we look at the first one, x minus 5. What does that tell us? X cannot be 5. What else? So that gives us this one here. Well, the middle one's x equals 0. That one doesn't work. And lastly, x minus 6 would be. So those would be our restrictions. Any questions on this here? Are we good with this here? Yes? Okay. We'll do this one here. And then we're going to skip the one after it. All right. We're looking at this one here. Now, again, we're talking about division, but we don't really divide fractions. So what can we do? Change it from division to multiplication. The first rational expression is not going to change. Our second one is going to flip. First rational expression doesn't change. The second one flips. And now we can do the exact same thing that we did for multiplication. Any questions on this so far? All right, so can we do anything with the 11x? No. How about the 3x minus 9? We can factor out of 3. And 3 factored out of 3x leaves us with x. 3 factored out of negative 9 will be just minus 3. So we have 3 times x minus 3. Here you go. So we have x squared minus 8x plus 15 and x squared minus 5x. Which one do we want to do first? The bottom one. What can we do with it? Yeah, we can factor out an x, which will leave us with x minus 5. We're pulling one x out, or we're dividing each term by x to simplify it. Because we'll write our x down and then essentially divide each one of those terms by x. And when we factor it out, we get x times x minus 5. Now the numerator will factor x squared minus 8x plus 15. Since we have plus 15, the signs are going to be the same, and they match the sign of the middle term. So minus and minus. The factors of x squared would be x and x. Now we need to look at the factors of 15. So 15 is 1 times 15 and 3 times 5. Which ones do we want to use? 3 and 5. Which gets us to this here. Now again, these are being multiplied together, so we can put it on one bar. And we can cancel out what's in common on top and bottom. So what is in common on top and bottom? Yes. And x. And this leaves us with 11 over 3. Now, this isn't always going to work out that we just get whole number answers or fractional answers. It's just worked out on these here that all the variables simplified out. Now, we do need to look at what our restrictions are. Now, for again, like the last one, the denominator, we have x minus 3 for the first one, and then the second one we have x and x minus 5. But even in the top of the second rational expression, what we're dividing, x minus 3 and x minus 5 are still there. Nothing's new on top. There's not something that's in top of this second one here that wasn't in one of the denominators already. So there's nothing new that we can add. or have to look for. So again, as we look for these restrictions, we're trying to see what value of x is going to make these three here be 0. And what would we have for this? 3, 0, and 5. And that's it for this here. Any questions on any of this here so far? As we're looking at these here, we're really just setting each one of these equal to 0 and solving. So here I would add 3 to both sides, telling me x is equal to 3, or what it can't be. Here we're pretty much done because it's saying x equals 0. And lastly, we would add 5. Can't do that. Any other questions on any of this here? We're skipping that one. I want to start looking at these here. Because I want to look at some of these here. And pretty much what we're going to look at the rest of these here isn't going to work out to be a fraction. We're actually going to have variables left over. Now again, when we look at any of these here, we might as well start off by flipping it. Changing it from division to multiplication. That's might as well where we go on and start with, instead of factoring first. Let's change it from division to multiplication. And then when we do that, we flip the second rational expression. The second fraction's flip. We keep the first one, we change the sign from division, our operation from division to multiplication, and flip the second fraction, which gives us this here. Let's have a little more room. Questions on this so far? Now we can look at factoring. Is there anything that won't factor or we can't do anything with? Well, there are two things. Yeah, a minus 2 and 2a minus 1, there's no greatest common factor with them, and because the degree for the exponents, the biggest degree we have for a minus 2 and 2a minus 1 is 1. So it's factored as simply as it can get. We can't get any simpler than these here. Now, the other ones we can. So let's look at 4a squared minus 1. There's something special with that one, isn't there? What name do we call that one? That one has a special property to it. Y'all remember? Yes, it's a difference of perfect squares. Because 4a squared is a perfect square. 4 is 2 times 2. A is, well, a times a. And 1's a perfect square. It'd be 1 and 1, yes? Since it's a difference of perfect squares, well, we'll have 2a and 1, 2a and 1, and the signs are opposite. Difference of perfect squares is kind of nice because they have the same two terms, just the signs are flipped. Well, what about a squared minus 4? It's the same thing. It's a difference of perfect squares. Well, a squared would be a and a. 4 is 2 and 2, and the signs are opposite. The signs are going to be opposite. Any questions on how we got to this point here? Okay. Well, again, these are pretty much going to be on the same bar. Now, we didn't write parentheses around it, but there still exists parentheses around these here. They're still being multiplied. They're not individual terms. And we can simplify some things out. Well, I think I saw some of you, a minus 2 and a minus 2, we can see that those two are the same. And 2a minus 1. So what we have left is 2a plus 1 over a plus 2. So that's all we would have left. Now, again, we have to look at the denominators. Well, one of them would be a plus 2. One of them is going to be a minus 2. And the last one's going to be 2a minus 1. Because those are our three that came out of the denominator. Now, the numerator of the second term, what's dividing? This here, the a minus 2. That there, well, it's already listed. We already have it. So we don't have anything else that we're being added in. So we only have to look for these three. So we need to see what makes a plus 2 equal 0. Yes. A plus 2 will give us negative 2, because if we subtract 2 from both sides, we would get a is equal to negative 2. The middle one, if we want to see what's going to make a minus 2 equals 0, well, this here would be what? Two, because we would add 2 to both sides to get it equal 0. Well, then we come to the last one. We need to see what makes 2a minus 1 equal 0. Well, this one might be a little bit harder to see, so we'll go on and write it out, because we can add 1 to both sides, which will tell us 2a is equal to 1, and then we would do what? Divide both sides by 2, telling us a is equal to 1/2. So our third restriction would be 1/2. So 2, negative 2, and 1/2 are our three restrictions for this one here. Are there any questions on any of this here? We good with this here? Yes? All right, let's look at another one. Find the quotient of y squared minus 9 over y squared divided by y to the 5th plus 3y to the 4th over y plus 2. Well, again, it's probably going to be best to start off by changing it from division to multiplication. That'd be a nice little change, and we have to do it anyways. And when we change it from division to multiplication, the first rational expression stays the same. And our second one, we flip it. So we're going to have y plus 2 on top, and y to the 5th plus 3 y to the 4th on bottom. Any questions on this here so far? All right. Let's go on and factor what we can. So looking at y squared minus 9, that will factor to what? Because y squared minus 9 is a difference of perfect squares, so we'll have y and y, 3 and 3. Y squared does not factor. Y plus 2 doesn't factor. But y to the 5th plus 3y to the 4th will. We can factor out a y to the 4th. It has a greatest common factor of y to the 4th. Let's see what that leaves behind. Well, if I take y to the 4th, if I factor it out of y to the 5th, I'm left with y plus. We didn't do anything to the 3. We didn't factor out any numbers or any signs, so that stays. And if I factor y to the 4th out of y to the 4th, it factors out completely, so I just have y plus 3. And what can we do next? And y plus 3 will cancel. What else will cancel?
Take the y off the top right, you take y off the y squared.
So the y plus 2 yes, if they're on top and bottom. Yeah, right, I mean, I opened the door intentionally for this. Because again, is there anything left in common on top and bottom? No. So is there anything else that we can do? No. And that's kind of the tricky thing, because when the teacher says, what else do we cancel out, we're assuming that there is something still there. But is there? No. So we're done. Because everything on top and bottom that is in common is already factored out. Now, again, there's a reason I said that, because some might be tempted with the y, with this here, especially since those parentheses aren't written in there specifically, to try to simplify that, but it doesn't work because the y plus 2, those are stuck together. That y and plus 2 are stuck together. So we can't do anything with that there. Now, really, what we can do is rewrite our expression. So on top, well, what we have is, we still have y minus 3, and we also have y minus, or not y minus, y plus, well, y plus 2. Because that's everything that's left on top. The only other thing we had on top simplified out, the y plus 3 simplified out on top and bottom. Now on bottom, what do we have left with? Y squared and y to the 4th. When the bases are the same, we do what? Add the exponents. So y squared times y to the 4th would be y to the 6th. Any questions on how we got to this here? Okay. Let's look at our restrictions. So we have y squared. Well, would that be the same as finding the restriction for y? Is the restriction for y squared going to be the same as the restriction for y? Well, the value when y is equal to 0, will that be the same as when y squared is equal to 0? Yeah, how about y to the 6th? Yeah, we're just multiplying y by itself more times, yes? It's just always going to be 0. So really, whenever we have a variable by itself, we know one of them is going to have to be that variable equals 0. So that's one of them. We also have, look for y plus 3, so I'll go on and list that. Y cannot be 0. Do we have any others that we need to look at?
Yeah, you need to look at, when you look at -3 and plus 2 because they're in the numerator.
Negative y minus 3 and y plus 3 here. These here are okay. Because when we come back, they came from this part here. So if the first one is 0, that's fine. We can have 0 divided by a number. 0 divided by 0 doesn't work, but that's beside the point. But the only other places we can't have 0 are these here. So we got the y's from here. Good. Well, we got the y plus 3 and the factored out from here. Good. Wait a minute. We forgot about the y plus 2. And this is sometimes why I wait to look at this until when I factored it to see, okay, we got this one, we got these, y plus 2. is the one we were missing, then yes, it would be -2. And this here is the first one we've really come across where the numerator of that second rational expression was different. It had something different that the denominators didn't have. Huh? Right, and the textbook again would say because it's left in the answer, it is left in the answer, but it's not left on bottom. So if it had y plus 2 on bottom, I would want to list it, but the book wouldn't make you. Yes. Yes. Any other questions on this here? All right. Let's look at this one here. Now again, the first thing I would do is rewrite this as multiplication. So we'll have a cubed plus 4a. A squared minus 16. A squared plus a minus 20. A squared plus 8a plus 15. Because again, when we do this division or dividing rational expressions, we're really taking it from division, rewriting it as multiplication, and then going from there. A cubed plus 4a. How can we factor that? We can factor out an a, yes? We could have done sum and difference of perfect cubes, but 4a is not a perfect cube. So I can factor out an a. Well, a out of a cubed leaves me with a squared. And a factored out of 4a leaves me with, well, just plus 4. Because we just factor one of the a's out. So each one's decreased by 1. What can we do with a squared minus 16? Difference of perfect squares, so we would have what? A plus 4 and a minus 4. Hopefully at this point the difference of perfect squares is kind of the ones you look forward to actually factoring if you're going to have to factor, because they're a little bit easier to work with. Well, let's just keep going in order. Let's do the top. A squared plus a minus 20. So since 20 is negative, our signs are going to be opposite. The factors of a are going to be a and a. Now we just need to look at the factors of 20. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. Which sets of factors look like they'd be the most helpful? 5 and 4. Do we want the 5 to be positive or negative? Positive. And we have these here. Now, if we check this, well, there we go. A times negative 4 would be negative 4a. 5 times a would be plus 5a, which would give us a positive a, what we're looking for. So that's the correct set of factors. Now, the last thing that we have to factor here is a squared plus 8a plus 15. Since the 15 is positive, the signs are the same, and they match the side of the middle term. So we'll have plus and plus. Now, the factors of a squared are going to be a and a. Now we need to look at the factors of 15, which are 1 times 15 and, well, 3 times 5. Which one would we use? All right, would 5 go in the first set of parentheses or second set of parentheses? Wouldn't matter, okay. Just making sure. And again, we multiply them together so they're on the same fraction. They're all part of the same rational expression now that they have been multiplied together. So what's in common on top and bottom? A minus 4 and minus 4. Anything else? Mm-hmm.
If you take out the a plus 4 from the a squared plus 4 and just got an a left, or would that, since it's in parentheses, doesn't matter?
Since it's a squared plus 4 is in parentheses, they're stuck together. Now, I did mention this in first hour. A squared plus 4 is technically factorable. It just doesn't have real factors. It doesn't have real factors. Because if we were to factor it, what we'd end up getting is a plus 2i times a minus 2i, which aren't real factors. When we're dealing with rational equations and rational expressions, we only want to factor real factors. And even if we did factor it, well, a plus 2i and a minus 2i is not going to factor with anything here. It's not going to simplify. And even if it did, well, a plus 2i and a minus 2i, if one of them factors, the other is going to have to factor also, which means, well, a squared plus 4 would have factored with whatever it was on bottom. So that doesn't factor, and that's everything is as simplified as it gets. So it leaves us with a times a plus 4 on top because everything else simplified. And on bottom, well, I have a plus 4 and a plus 3. That's what we get here. Now we still need to look at the restrictions. So I'm going to start off with first set of first rational expressions, denominator, which we have a plus 4, a minus 4, and the second one we have a plus 5 and a plus 3. And those 4 took care of the 2 denominators, yes? Now we need to look at the numerators of the second rational expression, a minus 4, a plus 5. Well, hey, we already have those listed, yes? So we don't need to list them again. Now, out of these 3 on the homework, it's really going to ask us for only what? A minus 4 and a plus 5, because those are the only 2 that are not listed that simplified out that are still not left in the answer. Because a plus 4 and a plus 3 still show up in the denominator of the answer. So a minus 4, what's going to make this equal to 0? Well, that would be. And for a plus 5, I'm going to get a nice purple. Because for me, I'm still going to go on and list these 2 here. Because for a plus 4, it would be negative 4. And for a plus 3, it would be negative 3. So I'm going to go on and list all the factors because that's just how I do these, because I want to know all of them. But if they're listed, most likely, especially on the homework, they're not going to have you spell them out if they're not already there. If they're already there. And that's it. That's where we're going to stop for today. We're going to finish this up tomorrow, because we'll do this here, and we're also going to look at these here. For the second term, what we're dividing by doesn't have a denominator, at least one not written. And that will get us through